Hey there, everyone. In today's teaching lesson, I would like to talk about getting or making API calls to fetch data from a YouTube API endpoint. So this is pretty cool. I just discovered this recently, and I want to share my newfound knowledge with you guys. So there's a few different things you can do with YouTube data, including analyzing titles, descriptions of the video itself, the duration of the video, which is the length of time that it runs, and you can get a bunch of other features from this data. Once you extract the data, you can do all kinds of interesting things, including making predictions into the future, like how successful will a YouTube video be based just on its title or a short description of the video. That's pretty cool. That's pretty easy to do. I'll show you how to do that. You can do SEO optimization. So search, any kind of searching and ranking. We're actually going to rank order these videos based on the title and description of the title. I'll show you how to do that. So that will leverage some NLP processing methodologies for that. You can do any kind of content trend analysis, audience preference, likes and dislikes, sentiment analysis, things like this. Title crafting, again, crafting your title to improve the clicks that you're going to get and the likability of the video overall. A lot of it has to actually do with the title and description. If people like that, they'll probably click on it. And if they like what they see, they'll continue to watch. if they don't even identify with the title, then nobody's going to click in the video and nobody's going to watch anything, right? So we're going to try to analyze that and understand that better and make some practical decisions into what types of titles are going to work best for your video, right? It has to be relevant to the video as well, but if you pick a really cool title that's relevant and meaningful, people are likely to click on it and engage with the video. So let's jump into it. I'm going to share all this code with you. It is a little bit complex, so I'm going to save this file as an HTML. With an HTML extension, you can download the file, double-click it to open it, and you'll have exactly what I have here. So you'll have all the code that you can copy and paste into your own Jupyter notebook and run it. So I'm not going to go into all the details. It would take way too long in the video. It would just drag on and on. But I will share this with you so you can copy and paste the code and run it in your own environment. Okay, so the first thing you need to do is get a YouTube API key. So you can do that right over here. I'll show you the site. Just click, and then we will flip back to the video. Okay, this is what it looks like on the YouTube side. Google owns YouTube, so all this goes through GCP, Google Cloud Platform. You may or may not have an account. If you don't have an account, you can set it up. It's free. It's very easy to get started. So go ahead and do that. I put the link for that right below here, right in my notes here. So I'm not going to run this in real time. In most of these videos, I do run it to refresh it so you can see it running and see it in live action. I'm not going to do it here because I would have to share my API key. I can't do that. That's very confidential and very classified, right? So I can't show that, but you can go ahead and apply for your own. Just pop that API key into this between the quotations over here, and you can run it, and it's going to run just fine. And you have all the other code. It's the only thing you're going to have to change, literally just change this one part right here. When you copy paste in your own API key, everything is going to run just fine. Okay, so you need that. So that is going to interact with the API endpoint. You go ahead and do a fetch, and you'll get things like title, description, channel, publish date, number of views, number of likes, okay, and number of comments as well, and the duration of the video. There might be a couple more features that you can extract. I think this list is pretty comprehensive. I didn't really beat this horse to death, but that is most likely the most common features that you're going to be interested in working with. If there are a couple more, you can explore that. I'm not too sure. I just did a little research, and that's what I came up with. So I printed all of these. You can see this in the display window right here. Let me scroll down just a little bit. You can see literally title, description, channel, publish date, number of views, view counts it's called, number of likes, that, so on and so forth, right? I did a search for data science and machine learning. That's what I'm curious to know about right here. So this could be anything, right? You can use this if that is your preference. This is the Q variable or the attribute right here. So this is the criteria that you're searching for. And again, it can be anything. So like I said before, you'll need your own API key and you'll need to do your search. You can use this one. I think this is relevant to the topics that we're discussing here on this channel. But it can be anything you want, right? So change that if you want something different. Let's scroll down a little bit and see what the next step is here. So we printed everything and it looks good. I'm going to do a quick sanity check and just scroll this window down a tad, okay, and we'll see all the printed out text there. That is pretty cool. I can tell this is working just by looking at it quickly. But in order to do something a little bit more substantial and meaningful, we're going to have to convert this into a data frame, and I'm going to have to do a little cleaning up of the data before I go ahead and push everything into a data frame. So I'm using regex here. RE is the library for regex. I'm going to do a quick match just to clean up the data a little bit. So regex is very cool and kind of complicated way to do almost any kind of data cleaning, data finding, recognition, searching for complex patterns in data. It goes beyond just a regular search or Control F if you're in Microsoft Word to find something. A regex process is a way to do do some kind of matching or cleaning on data that is somewhat straightforward. It's a little cryptic. It's a little bit cumbersome to work with, but you know the technology came out probably 30 plus years ago, and it was pretty good at the time. It never really evolved into a more easy to work with, more streamlined type of data processing. It just kind of got stuck as an anachronism in time, I guess, but never really evolved. But it is very good at what it's designed to do. So any kind of complex searching, pattern recognition, or cleaning, regex is by far the easiest way to do that. So we're going to go ahead and do some cleaning, get the hours and minutes into a format that's easier to work with, and then we're going to return hours and minutes, right? To convert all these longer videos that can drag on for more than 60 minutes, we're going to convert that into hours as well. So it's a little bit easier to work with. If you saw something like 600 minutes, okay, we can know that that's 10 hours, right? So it's a pretty long video, but if you had something like, I don't know, 379 minutes, how many hours is that? I don't know offhand, right? But once you convert it to hours, I think it's a little bit easier to understand this data. So that's what this function is for. And we're going to go ahead and push everything into a data frame. Again, I'm not going to refresh this, but I guarantee if you copy and paste in your own search term and your own YouTube API key, then everything will work. So I have this now in the data frame. What we saw before was the printed version. This is exactly the same data. It's just more structured in the data frame, so it's easier to work with, right? We can go ahead and do some plotting and charting. When you just print out text, you can't plot or chart anything. You can't really analyze it. You can't do any natural language processing on just raw text. You have to get it into a more structured format. So that's why we're using data frames here. So I'm going to scroll down just a little bit more and go ahead and look at the, these are counts now of the title. Yes, okay, so we're looking at the view count. The DF is abbreviation for data frame, and the title as well. So we're going to get the counts. We have over here, we saw the counts in this data frame. Number of views, number of likes, okay, number of comments, and then the overall duration of the video. So this is helpful. It's telling me which videos are the most popular in terms of number of views, but it's a little bit kind of messy there. There's a lot of data to look at. Some of the counts are pretty low. I'm not so interested in those low counts, and everything is kind of pushed together and mushed on top of itself. So it's kind of hard to read that, right? So I'm just going to look at the top 10, and you can make these charts bigger. You can do anything you want. I think the top 10 is a good way to break this down, because those are the longest running videos in terms of, in terms of views. These are the top watched videos. So probably the top 10 are the most relevant. You could look at the bottom 10 too. That would be just the opposite of that. But I think probably for what we're doing here, probably the top 10 is the most meaningful. So that's what this code is designed to do. We can see machine learning, was machine learning, introduction to machine learning. Then they have the date it came out this year, and Simple Learn. Okay, and the next one under that is Data Science in 5 Minutes, also produced by Simple Learn. Then the third one, you have Data Science Full Course. Learn Data Science in 10 Hours and Data Science for Beginners by Udrika. So the top number of counts got 4 million, I guess. That's a 4 million, and then or over 4 million, then just about 4 million, and just a tad under 4 million, or right at 4 million for the third, right? Those are the top three, and overall, we're looking at the top 10. So that's by view counts. Let's look at the like count. So very similar type of analysis here. Another bar chart, horizontal bar chart, and again, it's kind of everything's mushed together. So we'll look at the top 10. That's what this code is designed to do, and then you can see easily what really is data science told by a data scientist. So most people like that. It didn't get the highest number of views, but got the most likes, right? So two different ways of breaking down this data and understanding it. And again, number 2 is Data Science Full Course. That's by Udrika, and we saw that above. So I would say that course developer is pretty popular, right? He's in the top 3 above and the top 2 in this one. And in terms of likes, you have 140K and then 80K. So close to half of the number 1, and then it just goes down from there, right? Everything is sorted in descending order. So I think that's pretty useful. And now we are going to go ahead and do a scatter plot here. So let me move this out again. View counts and like counts. So these are the 2 metrics I think are the most relevant here from all these YouTube videos that have been posted on the YouTube site, of course. So view counts and like counts. So let me go down. We have the X and Y coordinates here, and we see likes versus views. And I put this into a color-coded chart so you can see the higher the number, the more shade of yellow, and then the darker the count, the more purple and blue and sort of navy color it is. So this is pretty nice. The only shortcoming here is I don't really know what this data point is. If I put my mouse over it, nothing shows up. It's pretty static. Not super useful here, and there's no description. There's no title. So this is just my first pass. I don't think this is going to fly with any kind of stakeholder or client that I'm working with. So I want to get more information about what these data points represent. Okay, so I'm going to rerun the chart here. Again, view count and like count. But now I'm going to add in a formatter to get the format of the counts a little bit better. I'm going to add in a title so I can see what I'm looking at. Like, what do these data points correspond to? So if I go down, again, we're using matplotlib to do the plot. This is static, not interactive at all. It's an older way of plotting. It's been around for a while. It's good in some cases, not super good for this. So this is more helpful now I have the title, but still the chart isn't interactive. I can't mouse over it. I can't zoom in. I can't zoom out. So I'm going to actually pick a different kind of chart to work with. This is called Plotly. I've done a few videos about Plotly charts. I like these a lot because they're very interactive. You can zoom in, zoom out, put the mouse over this, and get the pop-up of all the details. So that's the coordinate of the dot that's plotted. What really is data science? Okay, we can tell that's the title. And then I can put my mouse over any of these and get details about this, right? So this is a more useful plot, although we still have an issue with these guys down here. Everything is jammed up together. Kind of hard to dissect this. I can zoom in. Okay, that's a little bit better. Can put the mouse over it and you can see the details of the number of views on the x-axis and then the number of likes on the y-axis, right? So it is pretty cool, although it's kind of busy, and really if I give this to a client, I think they're going to send it right back and say, this is not super useful. I can't really use this thing, right? It's not usable. So I need something with more detail. If I put the mouse over it, I want to get the title popped up, and if the mouse is not over it, everything is spread out in the traditional scatter plot form, right? So it's easy to work with, it's easy to understand, but I get the details of the data as well. So this, we're going back to the very first plot that we saw, where we have the dots on the plot based on views and number of likes, right? But nothing's really popping up, but it actually does pop up when we put the mouse over it, because this is a Plotly plot. You can see the title. Okay, and of course you can see the views and likes. So we can have all the details. This is really the best of all worlds here, okay? You get the title popping up when you mouse over it. If you need to zoom in, you can certainly do that. You can zoom in, zoom out, scroll left and right, get all the details of the plot. Right. Here's the zoomed in view, and here's all my titles. So this is working pretty sweet. And the more views and the more likes we have as accounts go higher and higher, we get a yellow tint. In between, we have sort of like a greenish tint around 3 million. And then if the numbers are a little bit lower, we have more of a navy blue, or perhaps that's purple. Not too sure. But it's nice to see how the colors correspond to the frequency of the counts as well, right? And then, like I mentioned, when you mouse over it, everything comes into view. I mean, the title comes into view because that's what we plotted. So that's a pretty cool way to render the data and to interact with it. And for any kind of stakeholder or client too, they can make sense of this, right? You just put your mouse over that little dot there and you get all the details about that. So that's pretty useful. And now we can go ahead and move on to another exercise here. We can look at sentiment analysis. Okay, we're trying to take the title, description, and channel and try to create sentiments based on each of these features. Okay, so we have the original title, channel, title, description, channel. These are the first 3 columns in the data frame. Okay, this is what we pulled in from the Yahoo API, and then we get the sentiment over here: description sentiment, channel sentiment, and then title grammar, description grammar, and channel grammar. Okay, so we're getting more details. This is more of a natural language processing type of exercise, right? To extract more useful information from those titles, from those from the channel, from the description, right? That's what we're trying to do now. So in order to do that, we have to convert this language, which is English language, right, into more of a friendly format for the computer. So the computer doesn't really know what the channel is. If I go back over here, the computer doesn't know what data science is, or some instructor or some professor on YouTube is putting up videos about machine learning and AI and explained in 100 seconds. The computer doesn't know any of that, right? But if we use a TF-IDF vectorizer, we can convert all of this language into numerics, and the computer will certainly understand numerics, right? Any kind of numbers, 1, 2, 3, 4, 5, the computer knows exactly what that is. If you're talking about machine learning in 100 seconds, the computer has no idea what that is, right? So we have to vectorize all of these. Once we get this vectorized, we can look at the TF-IDF data frame view counts, like counts, right? We can join all this together, looking at the number of thresholds, or set a threshold, right, for higher counts or lower counts, understand the break off and the baseline for each of these, and try to make more sense of these titles, right, in more of a computer-friendly format. So now I've got the top features. So for the view counts, like counts, learning, HTTPS data, so on and so forth, I'm going to go ahead and create a word cloud. A word cloud is a way to visually look at the frequency of counts of words that show up in your corpus of text, whatever you're looking at here. So the high view count and low view count show machine learning, data science, HTTPS. So that is a secure URL link, right? When you see the S, it tells you it's secure. HTTP is hypertext transfer protocol. That is just a standard not secure, but whatever. So that shows up quite in abundance, I guess, because it's getting a high count. And the lower counts, if you look, all of these, they're very small in size here, are just lower counts of the frequency of that text, right? So the bigger, the more of it, and the smaller, the less of it. That's the takeaway there. So let's look at a random forest regressor here. We are going to, classifier, sorry, we're going to go ahead and use a little machine learning to understand the likelihood to predict like counts of a video based on the features, which include title sentiment, description sentiment, channel sentiment, title grammar, description grammar, and channel grammar. I won't go into all the details of machine learning. That's somewhat complex, but I have several videos on my channel already that describe how machine learning is done, how data science experiments are run, and things like that. So I'm not going to get into the nuts and bolts of it, but again, the takeaway here is the independent variables are the X variables. So all the titles, descriptions, and channels, and then we're trying to predict the dependent variable. That's the Y variable, and that's the number of counts, okay, and try to classify that and we can go ahead and run a feature importance exercise on this and see, based on the description, title, channel, and then the sentiment and the grammar for each one, which of these are the most influential to predicting the target variable, which is the like counts. And we can see description sentiment is by far the most statistically impactful. In this case, title sentiment comes up about 20% of the time. Description sentiment comes up about 60% of the time. So whether somebody will like a video or not is mostly based on the description of the video. The title has some input or some influence. I'm sorry. Between those two, you get about 60 plus 20, so 80% predictive power for whether or not somebody will like the videos based on the description and the title. The grammar used in the channel has maybe not even 10% influence, and the grammar of the description has somewhat of an influence, but lower, maybe like just over 5%, maybe 6%. Okay, so that's the feature importance to predicting the likelihood that somebody will like the video, right? This is a distribution of the duration of the video. So if we scroll down just a bit here, we can see most of these videos are under 100 minutes. We have a couple that go for a little over 300, 400, even 600. One goes for 700 minutes. So that's over 10 hours of video. That must be a pretty comprehensive course. Again, the topic we're looking at, the query that we did was relevant to data science. So that's probably some kind of data science training course that's pretty comprehensive. It goes for over 10 hours. So that's great. We have one of those. That's an outlier, but most of these are 100 minutes or less. This video, I promise you, will be under 100 minutes. I don't want this thing to drag on and on. And I start to lose people. I try to keep it tight and crisp and relevant to the topic that I'm discussing. And we will wrap it up pretty soon here. So another way to look at the results here is to go ahead and do a bar plot. So we're looking at a Seaborn bar plot, and we can look at the keywords that come up by channel and which keywords are the most popular based on the counts of those channels. So Simple Learn, we saw that at the beginning. Eureka, that is another popular channel. Krish Nat, apparently, if I'm pronouncing that right, that's pretty popular. Joma Tech, and rounding out the top 5 is Code Basics. So these are the top 5 most popular channels by number of counts, right? So these guys are pretty popular, and then you go down the list and it kind of falls off a cliff down the bottom here. Harvard University is like in the middle of this list, but you can see the in terms of popularity, it's not very popular at all. So, so that's kind of interesting. I thought an Ivy League school would be a popular channel for learning, but actually on YouTube you can get some very creative YouTubers that put together really phenomenal videos, and they do a tremendous job. Very creative, very entertaining, very engaging, very enlightening and informative. So some of these guys really do a great job. I would expect probably Harvard University would rank higher in terms of popularity, but it does not when it comes to data science, and that's fine, right? We're just analyzing the results here and seeing how things shake out. And Simple Learn is by far the winner here, right? So going down just a little bit more, we can go ahead and remove stop words from our corpus of text here. So we have title, and then title cleaned, and then description, and then description cleaned. Okay, so what is a stop word? It's things like the, and, is, or, in. I give a little description here in my notes. It basically gives little or no meaning and no meaningful contribution to what the language is talking about or what the title is about, right? Once we remove these stop words, things like and, is, or I don't add anything to the meaningfulness or the purpose of the body of text, right? So we want to eliminate those, because you can have a lot of does, ands, or ors, but is that something that that you really need to analyze and really understand the frequency counts of the word the? No, absolutely not. It's not going to add any value whatsoever to your analysis. So we're going to go ahead and eliminate all those stop words. So that's what this cell is for, to go ahead and get rid of the stop words. And then we're going to look at the top 10 trigrams and quadrigrams. So trigram is a combination of 3 words that will exist repeatedly together, and we're looking at the counts of these frequencies. So versus machine learning is easily the top trigram here. These 3 words appear more frequently than any other 3-word combination. So data science, machine, and science machine learning are the top three, right? Let me scroll down a little bit and get some perspective here. So of all these videos, 8 times versus machine learning shows up, and then about 7 times it's data science machine and science machine learning, and AI versus ML is the least popular of the top 10 trigrams. Let's look at quadrigrams. So these are 4 words that appear in consecutive order. Most frequently, we have data science machine learning. That totally makes sense to me. That's in 7 videos here. I think we looked at 50. I think the original search request was for 50. So, and 7 out of 50, data science machine learning shows up the most frequently. Then AI versus machine learning versus, so that's in between something, you can tell that. And then AI versus ML versus something else. So those are in between. So maybe it would be useful to get the top 5 or 6. You could just add those into the code they have above. It's very easy to make those modifications. I'm not going to do it, but this does give us good insight into patterns of words that occur over and over, and we can see these repeatable instances of words occurring over and over again. Okay, so now we're going to rank all these videos based on a few different features or columns. We're going to look at the vocabulary richness, the readability, the grammar, any grammar potential issues, or is the grammar done fairly well? So so somebody at maybe a 7th or 8th grade reading level can understand it, or is it very complex and sophisticated, or is it basically geared towards more of a child, maybe a 7 or 8-year-old child? When you're talking about machine learning and data science and deep learning topics like this, I don't think those are geared towards children. I don't think the audience is a 7 or 8-year-old, right? So I'm going to expect the grammar to be somewhat sophisticated and more towards somebody that's a little bit more mature, a little bit more educated too. And we're going to look at sentiment and then the length, the overall length of the description of the title or the description of the video itself. So that's what this is doing. Okay, so let's scroll down here a little bit and get these rankings. I think the ranking is very interesting because we can use natural language processing to understand how well is the title written, right? How well is the description created? We're going to rank the score based on that, and the overall vocabulary richness, the readability score, any potential grammar issues, or is the grammar fine, sentiment score, and then text length. Text length is pretty obvious, right? That's how long it is. And then the sentiment is basically positive, neutral, or negative. I would expect most of these to have a positive sentiment, maybe neutral. I don't think too many are going to be negative, but you never know, right? That's what we're looking at here. That's what we're studying for. So we're going to go ahead and score all these based on the rank. And if I scroll down, this is the original text that we had right at the beginning of this video when I kicked it off. Let me go down just a tad here and get this into view. Okay, scroll down the window a little bit, and we can go here. Okay, so you have all the details about the course, why I learned data science. I'm looking for my ranking. Okay, the metrics should come into view here. Okay, here we see the first one. So, oops, I skipped it. Okay, so the overall rank here is 170, vocabulary richness 0.41, readability score 9, grammar 16, sentiment 0.99, and text length 858. Okay, so that's the first ranking. Let's go down a little bit more. I'll give a little more details about this ranking in just a minute. I just want to see 1 or 2 more of these ranks, okay? And it should come into view. Going slow, I don't skip it. Okay, there it is. So the rank score. Second one, first one is what? 170, just over 170, right? This is 155, vocab 0.43, readability 8.6, grammar 24, sentiment 0.99, and text length 789. Okay, so this is pretty cool. I think we can actually take text and rank it in the order of how well it's written, what's the style of grammar, is the writing style good, is it not so good? I think it's pretty cool that you can actually take text and then rank it in a way that numerically orders it from the best to the worst. Okay. Now, if you want to normalize that, you can see some of the ranks go over 100. That's because we did not normalize it. If you want to normalize it and keep everything within a ranking range of 0 to 100, you could just go ahead and normalize that. That's very easy to do. I shared the code with you. So you could do either way. Get 0 to 100. That makes sense to me. These ranks tend to go over 100 because there's no guardrail set up here. So you could do either way. the 0 to 100 might be a little bit more intuitive, but if you didn't apply that kind of normalization or standardization to the data, then you will go over 100, and it's fine. It's working like it's designed to work. It's doing exactly what it's supposed to do. But if you see a rank over 100 for some audience members, it might not be as intuitive as if you had the rank from 0 to 100. So here I have in my notes, I won't go through everything. I'll wrap this up in a minute or two, but the ranking shows the overall score. So we're assigning metrics to the text. I think that's pretty cool that you're able to do that. The vocabulary richness is using type token ratio, abbreviated TTR, to get the tokens or the richness of the vocabulary. Like I said just a little while ago, the computer really needs numerics and it needs to work with numbers. It can't work with text unless you vectorize the text, and then you can analyze the text, right? That's why we're doing the TF-IDF vectorizer above. So we have a readability score here. 1 is very easy, and 20 plus is very cumbersome. It's convoluted. It's very complex. It's not easy to read. So ideally, to generate a high rank, 90 or above, you want something that is rich in vocabulary. It has a low readability score, right? So lower is actually better. If it's too high, it's going to be complex and you're going to lose people, right? You want to use good grammar, something that's descriptive, something that's meaningful, something that has purpose, right? When you're describing the video, and the title and the description too. And the sentiment too should be mostly positive. If you want to engage people, if you want to turn them off, you can have a lot of negative comments. I don't think that's people's objectives, right? Mostly if you post a video, you want people to watch it, right? You don't want them to be scared or be afraid necessarily, but I don't know, maybe that is the intention for some people. But the sentiment score ranges from -1 to +1, right? And -1 is highly negative. It's very maybe offensive, right? And there are some offensive comments on the internet, let's be honest, right? That could be someone's intention. But for most cases, most intents and purposes here, I think you'll see closer to a 1 sentiment score, right? That's very positive, optimistic, and very, very easy for your audience members to engage in. So that's what you're trying to do. So that's another thing to consider too, is to rank your own description and your own title of a video if you're planning to post some YouTube videos and you want to get the number of clicks up, the number of likes, and the number of views, right? So that's it. Just came across this recently. These are my findings when I did my analysis. I wanted to share that with you guys here. I learned something new when I was putting this teaching lesson together. I always try to learn new things every single day. Hopefully you guys learned a couple new things in the process of watching this video. That's my hope and my intention here. So I'm going to wrap it up. Thank you so much for your time, as always, and have a wonderful rest of your day. Goodbye.